Is Tesla Bot going to build the first Martian city? Are humanoid robots going to conquer space? Like with many things, the answer is not so straightforward. And today we're going to answer these questions with an engineer who is working on Martian missions. The topics for this video will be advantages and disadvantages of humanoid robots over conventional rovers, a real case of a humanoid robot in space, and what could be the future of humanoid robots on Mars. So let's start. Okay, so here we are with our guest for today, Paolo. Thank you very much, Paolo, for being with us today. And so what is your experience with Mars?
Well, I work for Airbus in the UK, and I've been working on space systems for a few years now. And in the last 4 or 5 years, I've been specializing in the exploration of Mars rovers in particular. So I've worked on the ExoMars rover, which is due to launch next year in 2022. And the rover I'm working on at the moment is the sample fetch rover, part of Mars sample return, which is more in a preliminary stage and expected to be launched later in the 2020s.
That's amazing. So, Paolo, in the last weeks, we've seen a growing interest towards humanoid robots. We've seen the Tesla bot, of course, from Tesla very recently. We've seen Boston Dynamics with its Atlas robot doing parkour. And these robots have for sure captivated the imagination of many people. And some people have started wondering, what if we use these robots to go to space? What if we use these robots like to build a colony on Mars or something like that? And the question is this science fiction or not? Because of course we're talking about robots, machines that are very different with respect to what you're working on. So what do you think are, for example, the differences, the advantages and the disadvantages of these machines?
Yeah, sure. I mean, obviously anyone who has seen the rovers that are on Mars can say that they are very different from humanoid robots. I mean, some of them might mount robotic arms, but that's about it. We all rely on wheeled platforms for the exploration of Mars, apart from one case, which is the helicopter, which is still very far from the humanoid form. So there are obviously considerations of walking machines for Mars, maybe not anthropomorphic in nature, but the wheels have a very consolidated design. So wheels machine have been around Earth for millennia. And the wheel as a locomotion device and also the drivetrain is a very old invention that we have consolidated through centuries. And so that is a technology that is reliable, is simple, and that's why we use it on Mars. Walking machines have a lot of flexibility, so you can use those when you have very rough obstacles that you need to climb on. But apart from that, they haven't had a lot of popularity in planetary exploration.
Yeah. There is, of course, a huge issue when it comes to controlling these machines with respect to controlling a wheeled machine.
Definitely, because a wheeled vehicle, you can park it anywhere. It can go as low as you want. You don't need to keep it stable. You can spread its weight along a very large base. And as long as the terrain is not too steep or with too many obstacles, you can do whatever you want with it. While a walking machine, especially if we're talking about a humanoid machine, which is a slender, tall figure, you need to keep it in balance at all times. It's something that we do without realizing, but for a control algorithm, it's very complicated to keep that in balance. So you have to always balance the loads on the legs, power the actuators to just stay on the spot, while wheeled rovers obviously don't do that. And that calls for a very sophisticated electronics, very quick to react and quite complex algorithm.
Yes, and electronics, as we know, is a very complex issue when it comes to space exploration for one very simple reason.
Yeah, not everyone appreciates that, but as soon as we go outside Earth's magnetosphere, electronics are baked in radiation. So the designs that we can fly away from Earth have to be very radiation hardened. Radiation hardened means that they can take a lot of energy from the radiations that they get from the sun and from cosmic radiation. And so they have to be simple. Big components, they take a lot of energy, they're not very quick. They're like electronics that we had on Earth 20 years ago. So they can't really run very sophisticated algorithms.
Yeah, exactly. And in addition to electronics, there is certainly an issue when it comes to power, the power that can move these machines, power source also.
Yeah, normally there is. Especially in my case, I'm thinking about Mars. On Mars, you can rely on solar power still, because you're not too far from the sun, but that is begins to be pretty weak. And also you have the day-night cycle, so you don't have a lot of energy throughout operations, and you need to keep yourself warm, so you need to dedicate energy to that too. You can fly a more powerful device like an isotope generator, but still they tend to be heavy, so normally you're very limited in power.
Yeah. A potential solution, of course, for this kind of humanoid robot could be a cabled solution, but then I guess we're talking about a more complex architecture of this mission with some central power source, which is then connected to all the humanoid robots. But still, I guess it's also different in terms of the power consumption of the actuators. So an actuator for a wheel is not the actuator for a leg or an arm, right?
It depends on the design. It could be similar technology, but that's where our technology is really not very well suited to move the humanoid form. The drivetrain for a wheel is very simple. You have an electric motor that spins and the wheel has to spin. So all you have to do is maybe adjust the spinning rate because you want your wheel to spin slower than the motor. But that's about it. And if you want it to turn, it turns. When you're out of energy, it stops. To balance a humanoid machine, it would be a far more complicated exercise because you have to translate that rotation into maybe only a translation or a rotation on another axis that is far away from your actuator, because you have to package all these things inside the human form, which is a very tough constraint to handle. It's not what rotary actuators want to do. It's very difficult to package those.
Yeah, exactly. And ultimately, even looking at the Tesla bot, we've seen a very limited, for the moment, breakdown of the actuators. They mentioned, I guess, about 40 electromechanical actuators, so quite a number of actuators. And when it comes to all these components, also complex components, there is a consideration that maybe people who don't work in the space sector think about, which is reliability.
Indeed. Definitely, yes. You will have a lot of moving parts. Our rovers have 6 wheels. In some cases, really for reliability. In case one breaks, the other 5 can still drag it along. But when you have something like a human form with so many actuators, you have a lot of parts that can break. And you have no possibility of maintenance in space, or at least you don't want to really be performing maintenance on your machines, even if you have astronauts up there. So that is a very important part. These machines have to be extremely robust. We fly everything with redundancy. We fly everything as simple as possible. So a humanoid robot, I don't think we are at the stage where we can even consider it being a mission critical machine because of the sheer amount of components and stuff that can go wrong.
Yes, exactly. We're talking about systems that have to survive for years, possibly without maintenance, a very harsh environment like, of course, Martian environment or space environment. So it's a very complex challenge.
Yeah, definitely. It also depends how exposed it is to the environment, I suppose. If it's inside a human habitat, it could be shielded from some of the radiations or the thermal environment. But if it's out in the open, which is really the advantage of robots, then yeah, it's tough.
Yeah, of course. But people might wonder that it's not just about movement. So we discussed a lot about movement, but people might say that the purpose of a humanoid robot, to have a humanoid form, is about manipulation, is about performing some general tasks like a human, like the kind of task that a human would do. And it's also something that Elon Musk himself has mentioned during the presentation, during the Tesla AI Day. He mentioned that he wants a general purpose robot with also 5 fingers to perform similar human tasks.
It needs to be able to do things that people do, and be a generalized, humanoid robot. For now we'll give it 5 fingers and see if that works out okay. It probably will. It doesn't need to be like have like incredible grip strength, but it needs to be able to work with tools. So carry a bag, that kind of thing.
And I was wondering, in terms of actual manipulation, where are we compared to the conventional rovers that you work on?
Yeah, that is fascinating because really the human form is not optimized for locomotion. It's a primate that has been optimized to carry around the head up on the horizons and carry around our hands, which are our main tools, our key biological advantage are our agile and flexible hands. Where we are with robots compared to that? Well, very far, to be honest. We have robotic grippers. They do a very good job at specialized tasks. When you have to design robotic grippers for a variety of tasks, it's still very challenging. You can design something similar to a hand, but by the time you are really interested in the level of flexibility of the human hand, all the possible degrees of freedom, different closures and spacing of the fingers, you are packing it with so many actuators that it becomes really heavy and bulky and difficult to control. And also the hands have the advantage of the sensibility. They are completely covered with sensors, with neural terminations that can tell us what we're doing. And it's very difficult to build that feedback inside the robotic hand. So we are still very far. In fact, if you look at the anthropomorphic robots that we have today, they rarely have hands. And if they have them, they're very simple, just open and close devices.
Yeah, even the famous Boston Dynamics robot Atlas doesn't have hands, just as these two. Exactly. These two things, like to pick up a box, but nothing more complex than that. And when it comes especially to Martian missions or lunar missions, they involve also some manipulation activities, like some construction activities. There are, of course, studies on that. Then what do we see in the robots that are planned to be used?
Yeah, I mean, certainly manipulation, moving loads, analyzing things, they all require arms. There's no question about that. And in fact, many robots, many rovers that we see on other planets and moons and whatever have robotic arms because they're extremely useful. So that aspect of, moving one payload from here to there or getting access to a tiny feature that we want to explore is very useful. And that happens to be similar to the human arm, just because it's a slender device that can position itself in space. It's not necessarily anthropomorphic because we want to achieve the human shape. And then to that, you attach the tool that you need. So if you have a specific task, like you say, analyzing a rock or constructing a base or doing something like that, you get the right tool on the robotic arm and you're pretty fine with it with the current robots that we have. So with specialized tools, they can perform pretty well in those tasks.
Yeah. So what we are probably implying is that for many activities, for several activities, maybe a conventional rover wheeled machine with a robotic arm could be fine enough. Maybe there could be some areas where a humanoid robot could be better.
Yeah, well, definitely. I think for a heavy-duty construction, you're good with wheeled machines. That's what we do on Earth. Basically, we have heavy-duty machines running on wheels around the construction site to move heavy loads and stuff like that. You will definitely need humans if you want to use a human interface. I think that is the biggest application of this, because most of the tasks external to a base that you want to build or around an area that you want to analyze, you can do them with wheeled robots and specific tools. But if you have a human interface that is already there and you want to take advantage of that, then it begins to make sense to have the human form. And I'm saying this thinking about, for example, the inside of a habitat that has been designed for humans, but is not yet inhabited by humans. So there, you could have an advantage in having an anthropomorphic robot that goes around and maintains the habitat or commissions the habitat in place of humans. And it uses the same interfaces, buttons, whatever that humans will use after the robot. But also there, it's a bit of a trade-off. It's, I would say it's not settled yet if it's maybe simpler to design the habitat to be just teleoperated or operated autonomously. So that could be an application, but not sure.
But while fine manipulation is at the moment out of reach, humanoid robots are already being used in space. An example is Robonaut 2. Robonaut 2 is a humanoid robot that has been used since 2011 on the ISS, in the International Space Station, and it assists astronauts with basic and menial tasks, like for example flipping a switch or turning a lever. It can also move around the station with these weird legs, which don't look very humanoid, but they're very practical for working on the International Space Station, which is a free-fall environment. In addition to its use on the space station, this kind of robot was planned to land on the moon in 2009, but the actual mission was never launched. However, compared to the Tesla bot, we're talking about a somewhat different machine, because the robot autonomy is very limited. This kind of robot requires supervision by the astronauts or the technicians, and can even be teleoperated by a human for more direct control. But still, it has very different objectives with respect to the Tesla vision, let's say. So, coming back to the Tesla bot, how is the potential future going to be? And talking about the future, I want to mention something a bit peculiar, because the machines that we design and develop for space applications are not necessarily futuristic compared to the terrestrial machines. Because, of course, there is a problem when it comes to the constraints, the environment, right?
That's right. Yeah, as I said before, like the case of the electronics, when you fly something to space, the general public, people tend to expect the latest technologies, the most advanced stuff it's sent to space, which is only halfway true. I mean, yes, they are advanced, but they don't look like the advanced technologies that we have on Earth. We can't fly anything that is close to an iPhone or whatever advanced device we have here, a neural network, whatever. It's all much simpler than that. Because when you fly something in space, you are facing a hostile environment, typically. So you could have vacuum, you could have extreme thermal environment, you could have radiation, and it all depends where you are. But typically you have these big challenges that make it very difficult for your hardware to survive. So you devote a lot of resources just to protect your hardware from the environment. Then you have the constraint of power. There isn't a lot of power available in space typically, unless you're very close to the sun, where, there is power, but then you have other problems like thermal. So you have to rely on limited energy to do all that. And so once you have all the shields, all the radiation hardened stuff, all the energy dedicated to thermal control and everything, the technology that you can fly is really not that advanced compared to what we have on Earth, because of the reliability, because of the radiation, and because it takes a lot of time to qualify things to go to space. For example, electronics, you take many years just to test them and to get them ready to fly. So even if you pick the most advanced technology that has just been released for whatever computer or smartphone, you would have a lot of years to prepare that for flight. And once you get to fly, it's already old.
Yeah. So I think this has possibly an impact on how we imagine the robots of the future. Maybe they're not going to be like we envision them right now. So what do you think could be like potential future direction for humanoid robots for space?
Well, for space, it's a very specialized environment. So as I said, maybe to maintain a base or something like that. But at the moment, to be quite honest, I see it more as a gadget, a humanoid robot in space. It could be something that you put as an experiment, like they have on the space station. But there isn't much more about it than that at this point in time. One big challenge is that our technology is not very well suited to be squeezed in the human form. So if we want to build humanoid robots, the way that Tesla seem to be doing it, or the way that everyone is doing it, as far as I know, is you take the classic mechanical devices like motors and gear trains and metal levers and all that stuff, and you try to squeeze that in the slender human form, which is not really designed to work with that. We work on biological tissues that have very specific mechanical capabilities. It's very complicated if you have to fit all the motors to move a hand inside your forearm. That can get very crowded, and to generate the force that you need, for example, to sustain your weight with your hand, it could be almost impossible. While a muscle does that very well, because this has been consolidated through millions of years. So from my point of view, we should be looking at the problem one other way. We should be looking at it the way nature solved it. If we really want to replicate this form, why don't we try to start with the building blocks that nature has used instead of the building blocks that we have developed for rotary joints, really, because our technology is developed to make things spin around one axis. So I think in ultimate analysis, probably we should start by being inspired more by biological tissues and see what we can do with those, or something that behaves similarly to a biological tissue. We could try to get an artificial muscle. We could try to explore different geometries, different materials, and make them grow and make them reach the same level of complexity that our fishes have. I think that would be very cool.
Yeah, that would be amazing. And so to answer to the main question of the video, it could be that one day Tesla bot goes to Mars. It might be that it's going to be a bit different from how we envision it. But in any case, let us know your opinion in the comments, how you would make this robot possible. And I also take the chance to thank Paolo very much for the presence, for the information that he gave us today, and especially thank you for watching. See you next time. And if you're interested, check out also the video we made about Spot from Boston Dynamics used for Mars exploration.